So yesterday we studied about the concept, basic concept of limits, and now we will be taking one basic formula which will be applied in case of limit. That special one which will be used in case of solving these type of limits. That is limit x tends to, let's take a function as x raised to the power n minus a raised to the power n upon x minus a. X tends to a. This is the function. Now see, if we look at this function, what are the similarities here? X minus a, some factor is there, it is raised to the power n, a is also raised to the power n. So whatever terms we are having in the numerator, that same term we have in the denominator. Okay? X is there in the denominator, a is there in the denominator. In numerator it is raised to the power n, and whatever number we have here, x tends to that a, right? X means whatever factor we have. Okay, so whatever we have here, that x should tend to whatever we have here, that is a. If we have this type of expression, so we can write the limit as n a. Okay, but if we don't have this type of expression, but if we have something raised to the power n minus something raised to the power n, so we try to convert it to this type of expression so that we can apply this limit. So directly we can apply this limit there, n a n minus 1. Okay, now similarly we have another one. Let's take it as first. Second, limit x tends to a, x raised to the power m minus a raised to the power m upon x raised to the power n minus a raised to the power n. So we can, if we have such expression, we can use this one, first one also, to solve this limit, but directly also we can apply the result, m upon n a raised to the power m minus n. Directly also we can apply this result, right? Either first one can be used, we can multiply and divide by the factor x minus a, so we can use the first one also, or directly this result can also be used, m upon n a raised to the power n minus n. Okay, so now and rest limits, if we want to find out, the basic concepts will be there. We will first of all simplify the function and then we will apply the limits. Now let's take some questions of exercise 13.1. So we will start from the simple one. Exercise 13.1. Let's take question number 1. A very simple question. Limit x tends to 3, x plus 3. The function is x plus 3. We will check whether it is in its most simplified form. Yes? Yes. This is there, so we can directly apply the limit here. So let's apply the limit directly. We can just put the value of x here and we get the result as 6. No need to do anything if the function is in. So let's come to this. Now what can we do here? Let's look at the question. It is x tends to 4, 4x plus 3 upon x minus 2. If we look at it, it is in its most simplified form. First thing that we have to check whenever we are applying the limit. Second thing that we have to check is the form should not become an indeterminate form. Either 1 upon 0 or 0 upon 0, right? So if we put 4 here, so we are getting some result. 0 is not coming in the denominator. So it is not an indeterminate form, so we can put the value of x. So yes, because we cannot simplify it further, or it is neither indeterminate form, so you can just put it. So let's just put it here. So we get 4, 4s are 16 plus 3 and 4 minus 2. So this becomes 19 by. Okay. Let's come to another one. Now we are taking question number 5. Limit x tends to -1. power 10 plus x raised to the power 5 plus 1 upon x minus 1. Yes, just tell me what can we do here. First thing that we have to check, simplest form. Second, simplest form. अब simplest form कैसे पता चल रही है इसमें? Can we factorize this one? No, we cannot factorize this one. That means it is the simplest one. The term in the denominator cannot be cancelled out with the numerator in any case. That means it is in simplest form. Right? Second thing is, after putting minus 1 here, are we getting indeterminate form? No. That means now we can put the limits. So you can just put the value of x as minus 1. So minus 1 raised to the power 10, minus 1 raised to the power 5, plus 1, and minus 1 minus 1. We'll simplify this. Minus raised to an even power is positive, minus raised to an odd power is negative, plus 1 upon minus 2. So we get the result as minus 1. Okay, note it down. Done? Okay, let's come to sixth question. Limit x tends to 0, x plus 1 raised to the power 5 minus 1 upon x. Now, if you look at this question, are you getting some form? Yes. What can we first of all, let's see whether we can simplify this thing. How? A question can be simplified in many ways. See here, you can apply binomial to simplify this. Yes, but that will be a very lengthy procedure. So we have learned a formula. Just now we have learned a formula, that is limit x tends to a, x raised to the power n minus a raised to the power n upon x minus a equal to n a n minus 1. Whenever we are having power to some factor, so we will just try to apply this one. Okay, 1 raised to any power is always 1. So we can write it as x tends to 0, x plus 1 raised to the power 5 minus 1 raised to the power 5. And let's look at the denominator. I told you whatever terms we are having in the numerator, same should be there in the denominator. So we can add and subtract 1. Yes, we can always add and subtract same thing to the question. That does not make any difference in the question. So we have made it as x plus 1 and minus 1. Okay, the question remains same. There is no difference in the question. Now what we can do, we can change the variable here. Yes, now here also you can do it in two ways. Either you change the variable or you add 1 and subtract 1 to this. Because if we compare it with this, whatever term we have here, whatever variable term, if x plus 1 is there, in the limit also it should be x plus 1 tends to 1. Right? So either you can do it that way or you can change the variable if it is easy for you. Why? How? Put x plus 1 equal to t. Now if x tends to 0, then t tends to what? What we have done, we have put x plus 1 equal to t. Okay, if x tends to 0, ye let kara put. Okay, so t tends to 1. X tends to 0, so t tends to 1. Now our limits will change. So we can write it as limit t tends to 1. In place of x plus 1, we have put t, so t raised to the power 5 minus 1 raised to the power 5 upon t minus 1. Let's compare it with the question, with this concept. Is it similar? Yes. Now it is t raised to the power 5 minus 1 raised to the power 5 upon t minus 1 and t tends to 1. So we can directly apply the limit, that is n a n minus 1. So this is, n is, what is n here? What is n here? 5. N is always the power. 5. What is a here? 1. A means this constant term that we have. So a is 1 and n minus minus 1. So we get 5 into 1 raised to the power 4, that is equal to 5. Okay, so this is how you have to convert the question. Directly ये वाली form नहीं given होगी, हमें convert पढ़ना पड़ेगा उस form में. But how will we see that how can we convert it to that form? Whenever you are having variable raised to some power, so you just try to convert it to that. Okay, note it down. Any problem in this? Ninth is simple. Let's come to look at question number 7 and 8. One of them we can do. Which one? Let's take question number 8. Limit x tends to 3. X raised to the power 4 minus 81 upon 2x square minus 5x minus 3. Now, is the function in its most simplified form? No. We can factorize this. We can factorize the numerator also, we can factorize the denominator also. So it is not in its most simplified. First of all, let's check whether we are getting an indeterminate form here. If we put 3 raised to the 4 is 81. We are getting 0. Let's put 3 in the denominator. What do we get? 18 minus 18. 5 is 15 minus 3. Again, it is 0 in the denominator. So form is 0 upon 0 indeterminate. So we cannot put 3 directly. We have to factorize this, right? So let's factorize this. So we can write it as x square whole square minus 9 square. And in the denominator also we can find out the factors. What are the factors? 2 3s are 6. So we have 2x square minus 6x plus x minus 3. This is now a square minus b square, which can be written as a plus b, a minus b. So x square plus 9 and x square minus 9. And denominator, we can take 2x common, x minus 3 plus 1, x minus 3. Limit x tends to 3. Further, this is a square minus b square. 9 can be written as 3 square. Further, it can be simplified as x plus 3, x minus 3. So this is x square plus 9, x plus 3, x minus 3. And denominator becomes x minus 3 into 2x plus 1. Limit x tends to 3. Now we can cancel out some factors from here. We can cancel out x minus 3. Right? And as this one factor cancels, our question is now simple. Further, we cannot cancel out any factor. And if we put x equal to 3 here, look at the denominator, we are not getting 0 in the denominator. Yes, so indeterminate form khatam ho gayi. So we can just put the value 3. Now you can apply the limit. So this is 3 square, 9 plus 9, 3 plus 3, 6, and 2 3s are 6 plus 1. So we get the result as 18 into 6 upon 7. Right? 6 8 are 48, 108 upon 7. So this is the answer. Yeah. So firstly, the first step that we have to check whenever we are applying the limits, whether by putting that number, are we getting the indeterminate form? If we are getting indeterminate form, so we have to factorize that or we have to simplify that function. Okay, and after simplification, some factors will cancel out, and then we can put the done. Okay, let's come to the next one. You were asking for question number 9. 9, look at 9 question. It's very simple. Just put x equal to 0. Are we getting indeterminate form? No, we are not getting indeterminate form. So we can directly put this x. 9. Limit x tends to 0. Ax plus b upon cx plus 1. So if we put x equal to 0, we are not getting indeterminate form. So we can directly put the result. No need to factorize it or a factorize really. So we just put 0 here. And we get the answer as B. Now let's take question number 10. Z, limit z tends to 1. Z raised to the power 1 by 3 minus 1. Z raised to the power 1 by 6 minus 1. Now, are we getting some form here? The limit that we have written in the starting? Yes, second form. This is the second form, that is limit. We can compare it with x tends to a, x raised to the power n minus a raised to the power n upon x raised to the power n minus a raised to the power n, which is m upon n, a raised to the power n. Yes, so if we just compare it with this, so we are directly getting the result. 1 can always be written as raised to any power. According to the concept, we can give the power to 1. And now directly we are having the result. Look at it. It is z raised to some power minus a raised to the power n, z raised to the power n minus a raised to the power n, and it is z tends to a. Okay. So this is m by n. What is m here? 1 by 3 upon n 1 by 6. So we are writing it as 6 upon 1. Taking the reciprocal, a is 1, m minus n. 1 by 3 minus 1 by 6. So we get it as 2, 1 raised to 6 minus 3 upon, what will be the result? 6 is there. So 2's are 2 minus 1. Upon 6, that is 1 by 6. And but we know that 1 raised to any power is always equal to 1. So we get the answer as 2. Note it down. One more method is there for this. If you don't remember this formula, you remember only the first one. So what you can do here, you can multiply and divide by the factor. What was this was second one. What was the first? It was limit x tends to a, x raised to the power n minus a raised to the power n upon x minus a equal to na minus 1. So we need the factor x minus a here. right? So what we can do, we can multiply and divide by z minus 1. Okay? And multiplying and dividing by z minus 1, we again will get this term twice. Once it will be in terms of 1 by 3 and another it will be in terms of 1 by 6. So you can apply the limit and same result we can get from there. Let's come to question number 12. Done? Limit x tends to minus 2, 1 upon x plus 1 upon 2 upon x plus 2. Let's check whether we are getting an indeterminate form. If we are putting the value of x, yes, we are getting an indeterminate form. This becomes minus 1 by 2 plus 1 by 2, 0, and this becomes minus 2 plus 2, 0. So we have to factorize this. So let's factorize. If we are taking the LCM in numerator, we get 2 plus x upon 2x and into x plus 2. Limit x tends to minus 2. So we can cancel out this factor x plus 2 and now we get limit x tends to minus 2, 1 upon 2x. And now we can put the value of x. Is this clear? Whatever term upon में जो भी term आती है, that goes in the denominator. ठीक है? Vishant was looking like this, so I thought this is what he has not understood. Yes? If we are writing something as, let's say, 2 upon 3 upon, okay, write it as 5. So we can write this term, it means it is 5 upon 1. Okay, so we can write it as 2 by 3 into 5. Okay, so 3 comes in multiplication to 5. This is what we have done here. Now put the limit and we get the answer as minus 1 by 4. Now further we have some trigonometric ratios, limits based on trigonometric ratios. So we are having a new concept for that. Some more limits, limit concepts or limit formulas we can say we are having in terms of trigonometric ratios, right? So we'll be taking them tomorrow. Okay, up to question number 12, whatever question, 1 or 2 questions are left, you have to complete them. Completed just now, we are having 2 minutes or 2 or 1 minute is left. You can just complete them.